Alright, so in this video, I'm going to solve an interesting exponential equation. So my equation is 100 to the power of x is equal to 400. And I want to find the value of x. So we see that x is going to be in between 1 and 2 because 100 to the power of 1 is 100 and 100 to the power of 2 is 10,000. So it's going to be more closer to 1 than it is 2, but it's going to be somewhere in the range of 1 and 2. So to solve this, what I'm going to be using is logarithms. So I'm going to first start by taking the log on both sides. So I get log 100 to the power of x is equal to log 400. And if I have something in the form log a to the power of b, I can move this exponent of b to the front, so I get b times log a. In this case, I have log 100 to the power of x. I can move x to the front, so I get x times log 100 is equal to log 400. Now, I'm going to take the log of base 100. So, log base 100 of 100 is just 1. And log base 100 of 400, well, 400 is the same thing as 100 times 4. So I can rewrite this as log base 100 of 100 times 4, which is equal to log of 4 over log of 100. And I have 1 plus this because of this. So now log of 4 is the same thing as log of 2 squared. And log of 100 is the same thing as log of 10 squared. So I can move the 2 to the front and the 2 to the front over here. So I get x is equal to 1 plus 2 log 2 over 2 log 10. These two cancel out, so I get x is equal to 1 plus log 2 over log 10, which is equal to 0.301. So x is equal to 1.301. Alright, so in this equation, I'm going to be solving 9 to the power of x is equal to 36. So to start, my variable in this equation is x, which is what I'm going to be solving for. And we can already tell that x is not going to be a whole number because 9 to the power of 1 is 9 and 9 to the power of 2 is 81. So we know that x is going to be somewhere in between 1 and 2. So we want to find the exact value of x. So to do that, what I'm first going to do is take the log on both sides. So I get log 9 to the power of x is equal to log 36. And the reason I used logarithms for this is because they have a special property that states that if I have something in the form log a to the power of b, I can move this exponent b to the front, so this turns into b times log a. So before, x was an exponent, and it's almost impossible to solve the equation just in the form x is. But now we can move x to the front and make it equal to a whole number, and now it's much easier to solve for x. So now I get x times log 9 is equal to log 36. And now, obviously, we want to isolate x, so I'm going to divide both sides by log 9. So then these two cancel out, and I get x is equal to log 36 over log 9. Now, we aren't done yet because we want to find the exact value of x, so we don't want any logarithms in our solution. So now what I'm going to do is I'm going to rewrite log of 36 as log of 9 times 4 because I just want to simplify log 36. And now I can use the property that states that if I have something in the form log a times b, this is equal to log a plus log b. So in this case, I have log 9 times 4, and we can say that a is 9 and b is 4. So this turns into log of a, which is 9, plus log of b, which is 4. And remember, I still have all of this over log 9. Now, if I have something in the form a plus b over c, this is equal to a over c plus b over c, and this is just using fraction properties. So I have log 9 plus log 4 over log 9, and I'm going to rewrite this as log 9 over log 9 plus log 4 over log 9. Now, anything over itself equals 1, so log 9 and log 9 cancel out, and I get 1 plus log 4 over log 9. Now from here, I'm going to simplify this by rewriting log 4 as log of 2 squared, because 4 is equal to 2 squared. And I'm going to do the same thing to log 9. I'm going to rewrite it as log of 3 squared. So now remember that if I have something in the form log a to the power of b, this is equal to b times log a, because I can move b to the front. So I'm going to be reusing this property on these two terms. So log 2 squared, I'm going to move the 2 to the front. And same with log 3 squared, I'm going to move the 2 to the front. So I get x is equal to 1 plus 2 times log 2 over 2 times log 3. And now I can cancel out these 2's. So I get x is equal to 1 plus log 2 over log 3. So now from here, log of 2 is equal to 0.3010, and log of 3 is equal to 0.4771, meaning x is equal to 1 plus 0.301 over 0.4771, which is equal to 0.6309. So 1 plus 0.6309 is 1.6309. So this is my solution.